All right, so I'm gonna get started. So my name is Gloria Fonseca Alvarez. I am a member of the community science team, and I'm going to be talking about the visit images and source tables and for source table. Welcome to the Rubin Data Academy. I'm assuming most people here are still from the past session. As a reminder, if you have any questions, you can always post on community.lsst.org. And if you do end up using the data preview one, please cite it. There are instructions on these various links. So for today, we're going to cover some key concepts related to visit images and source tables, and then we're going to cover a few different tutorials. I think I can get through all of them, but we'll cover both using the portal and the notebook aspect. So to start, some key concepts. What is a visit? A visit is a single observation or an exposure. For the DP1, these are 30-second exposures. The DP1, the data comes from the LSST commissioning camera, which has 9 detectors, so 9 CCDs. And a CCD visit refers to like the visit, but for like a specific detector. And finally, a visit image is the fully processed image for a single detector for each visit. There were a bit less than 1,800 visits that are included in the DP1. And the information about all the visits are included in the visit table. And there's also a CCD visit table that includes the information for each one of the detectors. So as you can see, it includes 9 times as much, as many rows. Now for the LSST, we use specific definitions for the term source and object, where the source is a detection in a single process visit image, whereas the object is an astrophysical object at a specific sky coordinate that it doesn't change. Um, the source table contains measurements made on objects, so a specific location, in a process visit image. And as you just learned from the object table, that contains measurements done on the deep COAT images, which are the combined visit images. There's also force photometry. So like if a certain measurement doesn't meet the threshold to be considered a detection, we can still get some photometry information using force photometry at a particular coordinate. Now, starting from the raw images, there's a lot of different processing that goes into producing the data products. So to start with image calibration, so the first thing that happens is you have instrument signature removal. So this accounts for detector effects. And then the next thing is subtracting the background, so removing the sky background, and then both astrometric and photometric calibration. So this allows you to map from the pixel coordinates to the sky coordinates and also correct for any attenuation, like from the atmosphere. And that allows us to get actual like flux units. There's also PSF estimation. This tells you the shape of a point source on the detector. And after all of this calibration, we get the visit images. And as I mentioned, there's one per detector per visit. Now, the next thing to do that happens to the visit images is that there is source detection and measurements. So a detection is a measurement that has a signal to noise ratio of greater than 5. And some of these detections might also be blended. So there's a deblending process with this scarlet light. And this is just like an example of that process. And then after the deblending, there's the measurement of the fluxes. There are many, many different fluxes that are included in these tables. Some of them are like the PSF flux, Gaussian flux, and aperture fluxes. And there are also measurements on shapes and size. And finally, this all comes together into the source table. There are other tables that have photometry information as well, like the force source table. So like I mentioned, there's force photometry. You can do force photometry at a specific location. So from the deep COAT images, we get object detections. And then, so those have coordinates. And then we go back in and at every visit image and every difference image, we do force photometry at those locations. Now this, for the force source table, the fluxes are only PSF fluxes. But this is the table one of the tables that can be used to evaluate, for example, like variability of objects. Now the actual data products, they can be accessed via different ways. The visit images can be accessed via the Butler, and as well as the simple image access, which you might be familiar with. And you can also access it via tap. Um, if you're using the Butler, there's specific data set types for the visit images. The data set type is visit image, and you need specific information to access, like for example, the band, detector, like visit information. And then this will become obvious later, but there are different calibration levels to the different types of images. The visit images have calibration level 2. Now, all of the images come with both pixel data and metadata. The pixel data are two-dimensional arrays, and they come with 3 different kinds of things. So there's the image plane. So that's probably what you might think of as like the image. But there's also a variance plane, which tells you the uncertainty. And then there's a mask plane. So there are several different masks that exist for the images. And this just lets you see what they are. And then the metadata tells you things about the visits, like the PSF and the calibration, and also the world coordinate system. Now the source table that we recommend that you start accessing the tables using TAP, but you can also access it via the Butler dataset type source, and it also has specific things that you can, specific information you can give it to access these. Some key columns for this table are the source ID. So each source has a specific ID. You also get visit information about the detector, the band, coordinates, and many different fluxes and many flags too. For the four source table, you also have very similar ways to access. This one has some very useful columns like the object ID. So all of the different measurements in the different visit images are associated to the same object ID. So that's why it's useful to to that's why you use this one for to make light curves, not the source table. But it also has visit information. Notice that the coordinates are actually different from the source table. This one has chord RA and chord deck. And also it has fluxes both on the visit images and the difference images. Now to start, we're gonna start with the portal, and I'm gonna see if I can copy this actually and put it in the chat just in case anyone wants to follow along. So I'm going to switch over to the Rubin Science platform. And I'm already signed in, as you can see here. But there are different ways to interact with the data. There's the portal, the notebook, and the API aspects. We're going to use the portal first. So as you can see, there are different tabs up here. Since I'm interested in querying for some visit images, I go to the image tab. And you can select everything like by hand here, but just to save some time, I'm gonna use an ADQL query, which I pasted in the chat. So I'm going pretty fast here, but I went to the images and I clicked on Edit ADQL, and you can just paste the query here. And we're going to be querying for visit images around the center of the extended transitive field south, which has these coordinates. And we're just grabbing a bunch of commonly used columns. But yeah, so I've pasted my query and I'm just going to click search. Okay, and it seems my query has, oh, okay, success. Okay, so now we have an image. If this is your first time accessing any of these images, congrats. You've now accessed some LSS, some Rubin Observatory data. But I wanted to start with the coverage tab here, just because it's a bit easy. It's easier to visualize what exactly is going on. So as you can see, there are different panels here. So here it gives you like the actual data products. There's a default chart here, and you have a table. So the table here gives you the information about all of the 214 visit images that were retrieved. But you can, if you just like scroll through each one, you can see what exactly it looks like when you have a different visit. You see that there's certain pointing and different orientations. And for our particular query, we only requested images in the R band. And as I mentioned, they have calibration level 2 since they're the visit images. But I'm going to go back to how did I get the coverage map displayed? So the default is the data product tab. Coverage is right to the left. I hope that answers. Okay. All right. So this is just one image. We got a lot of different images. To actually look at some more, you can click on this little grid and you can see multiple images at once. And if you just scroll through the table, I think it automatically changes the grid. Um, But I'm going to go back to a single image since I wanted to show you the other plane. So you see that there are three things here. So this is like the image, and then if you click right here, it should go, it says it's the mask plane. And then you also have the variance plane. So it allows you to see like the uncertainty. Um, but yeah, and you can play around some more with like showing different masks. For example, if you click on mask, you can go to see what was the different detections here. But yeah, we have a lot of different tutorials to show you how to play around with the images. But next up, I wanted to also show you how to access um, catalog data. I'm going to paste this in the chat as well. Yeah. Okay. So since I'm going to query catalog data, now I click on the catalog tab. And once again, I go to ADQL and just paste the um, the query. And I'm going to grab this visit information as well, since that will come in handy. But yeah, so just click search. And you'll see now here in the table, that's like the results from the source table. So you'll see here that it has all the information for one single visit. So all of these are different detections in one image. But if you go to the data product tabs, you see that it has overplotted it with the image. But this is one of the images, right? It's not necessarily the one that we queried. So you can actually, I believe that's correct. If you go to, you can actually go between the different things that you've queried. But I'm gonna go back to my original query with the visit images. And if you go and find the visit, you can paste the visit that you used for the other query, and that should give you the results only for that one image. So now you have um, the all the different sources overplotted with the correct image. But yeah, so that's all that I have for the portal. I'm gonna pause if anyone has any questions. Now I'm gonna go back to the science platform since we're gonna access the notebook aspect. I'm gonna zoom in a bit more. Okay. Okay. We have a super useful landing page with lots of links. But if you go to the tutorials tab, you can find all of the tutorials for all of the different data previews. And I'm going to start with going through the catalogs. So you can find that under DP1 and then data products. And there's a catalogs. And I'm going to start with the source table. And since I've opened this up before, it's going to ask if I want to overwrite, but um, yeah, and I'm gonna zoom in even more. Okay. So this is one of our tutorials. It tells you here different ways to access the source table. So you have tap, and all of our DP1 tables are DP1 dot name of table. And then you can also, it tells you how to access it using the butler. But for this particular demo, I'm just gonna use the tab. But we start with just importing some packages. You want to import your tab service. And to actually run the cell, you just shift enter, or you can do this little play, I think. But you first want to instantiate the tab service, and then to start the butler, you tell it what collections you want to use. It's just LSST ComCam DP1. I'm going to do this even though I'm not going to actually use the butler. And then we also start with like defining some colors for our different filters. So if you've never looked at these tables before, it's useful to start with looking at the table schema. So we do all of our queries using ADQL. This is the typical, I guess, the setup for a query. You select some columns from some table where it meets some conditions. And as a reminder, we suggest that you do your queries asynchronously, so you submit the jobs and then later retrieve them. So this just shows you all of the different columns that exist in this table. There are many, 156 columns. It includes, coordinates, different types of fluxes, visit information, detector information, and a source ID. Now, likely you probably won't need to start with all of those different columns. So I'm gonna just show you all of the most commonly used columns in the next query here. So we've defined a list of all these uh, most used columns, and we're just gonna retrieve the information for just those. So there's the RAN deck, your position, PSF flux, with its error, an extendedness parameter. So this is what can help you identify something as a point source or if it's an extended thing. And this is done using a flux ratio. And then you can get the visit ID and then a source ID. So far we've just looked at the schema for the table. We haven't actually accessed any data. So some suggestions before doing that. Please avoid you doing full table queries. You can include some sort of coordinate constraint, or if you know visit information, you can use that as well. Also, like I mentioned before, with source table, is not a light curve, right? You want to use the for source or the different difference of image analysis tables for the light curves. So I'm gonna just do a demo query here. So here we're just selecting some of those key columns and from the source table, and we're gonna query around a 2 arcsecond radius around the center, around these coordinates that are near the center of the extended Chandra field south. But yeah. And then I'm gonna display what the results look like here. But yeah, so the source table just will just show you the source ID. You can see that there are many for each, and each visit has a different source ID. You get your coordinates, your flux, and your error and extendedness, which is like 0 or 1. But one of the things that you might be interested in doing is seeing if any of these visits have multiple sources that were detected in that same radius. And you'll see that at least one of the visits has 2 sources within that search radius. But if you want to see for like what the distribution around that in that search radius is, you can calculate the offset of the positions and plot them. So this is just that 2 arcsecond radius, and all of the different sources are pretty close to the middle. But yeah. You can also join the source table with other tables, like so the visit table has information about the date and also has band information. So to do a table join, you just join with the visit table where the visit in the visit table equals the visit in the source table, where we're just gonna look here in the same around the same coordinates. And something super useful can be like, for example, you want to look at only like visits for like a specific date that you might be interested in. So this joining with the visit table allows you to do that. So here we're just looking at visits between these two MJDs. Now I can retrieve the results. Um, and I'm just gonna once again do the same similar kind of plot, but for only the visits between those dates. And you can also do it by filter. So you see here, there's a lot less sources, and they're more concentrated around the center. Um, but yeah, so that was a little peek into the source table. Does anyone have any questions before I move on? Okay. I'm gonna go to the force source table next. So that once again is under DP1 data products, catalogs, and then force source table. I'm gonna overwrite again. Okay. So for the force source table, the tab table name, DP1 dot force source, and the Butler name is object force source. But we start again with importing our packages, starting the tab service, starting the Butler, defining our colors and symbols. And then we're going to start again with looking at the table schema. So some of the columns that are in this table are object ID, which is the unique object ID based on that those like detections in the deep coads. It tells you the ID of the parent. If the source was like deblended, you can get the object ID of the parent. You got some coordinates, visit information, PSF flux. Once again, for this table, the fluxes are only PSF fluxes. And then you have various flags. But yeah, so I'm gonna show you some of the definitions of the key columns, the object ID, coordinates, visits, detector, band, and both the PSF flux on the visit images and the difference images. So this table is a bit longer than the other one, since it has measurements on each one of the images, not just after a certain threshold. So there are a couple of different ways that you could make the search smaller. You can only retrieve photometry for a certain object, or you can retrieve only things for a certain visit image. So for this particular demo, we're gonna go the first route. So first we need to obtain this object ID. So we have some coordinates from an object. It's a variable star, and we want to know, well, first, you want to know if there's even, like an object matching that, so that's useful too. But so you start by querying the object table, which we did in the previous session, grabbing the object ID and the coordinates in case you want to, make sure that it actually matches. But we're going to query 2 arcseconds around those coordinates that we're interested in. And there's actually a result as expected, and there's only one. But yeah, so now we have an object ID for these coordinates, and now we can move on and actually query the force source table. So for that, we're just selecting some of the commonly used columns, object ID, band, PSF fluxes from the DP1 force source table, where the object ID is the one that we just searched for. And I think that just printed out the query as well. And you see that the resulting table has 219 rows. As I promised, the object ID is the same for all these measurements, and you can see that has measurements in all the different bands, visit information, and the flux. So the first thing that we can do is try to get some, statistics on these. You can grab like how in each band, how many you can see how many different measurements there are, the minimum flux, mean flux, maximum flux, and the standard deviation. So you see here that there are different number of like images in each of the different filters, with the R band for this particular thing having the most. Now, if you want to make a light curve, you need to get information about the date, which is in the visit table. And in this query, we're also gonna go the extra mile and do a triple table join with the object table, since that has some the fluxes from the deep coads. So here we're selecting a bunch of different columns from each one of the different tables, which are denoted by here, like V is the visit table, FS is for source, and then O for the object table. And we're joining the visit table with the for source using visit, and we're joining with the object table using object ID. And once again, we're only querying things for that one object. Now we can plot a light curve since now we have information about the date. So this shows you the PSF flux versus the MJD and the PSF difference flux versus the MJD, and with some with the fluxes from the object table over plotted here. So as you can see in the PSF different flux, the flux can actually be negative. So do pay attention to that. But yeah, I think that's all I had for this particular notebook. And I will pause for questions. Now, lastly, I wanted to show you how to reprocess the visit images. Um, So if you go to DP1, how to use RSP tools, you'll see there's an area that says image reprocessing. So you can do, if you so wish, reprocess the images. You can detect and measure sources. You can do your own force photometry, inject your own sources, do your own background subtractions. But I'm just going to show you how to do your own source detection. Okay. So for this, we're gonna use some specific packages. So the LSST.MEAS algorithms and base. So this allows you to access some high-level pipeline tasks to do source detection, deblending, and measurements. So the little tasks are source detection, source deblend, and single frame measurement tasks. But yeah, so we're gonna actually, for this tutorial, we will be using the butler. We just import the butler, import the different tasks, and then also, since we're gonna display an image, we want to import the AFW packages for image display. And then we're gonna start the butler. So for this particular demo, we just want to grab any image really. So we're just gonna grab the first image around the center coordinates of the extended Chandra Deep Field South, which are once again these. And then we're gonna set how we want to display our images. So we're gonna use the Firefly backend, but you can also use things like Matplotlib. But and that should open up another window. Now I don't know if this has changed, but if you do close this, eventually you might have encounter issues, so I don't recommend closing that. But you can actually move that to the side so you can look at your notebook and also your images. And I'm gonna make that a bit smaller. So now we've set up the image display, and now we want to actually find some visit image. So we're gonna set up some query that will pick a specific band and overlapping a specific point. And we're gonna set that band to be the R band and the coordinates to be the RA index that we defined earlier. So now we want to find the reference to those images. So we do butler.query datasets for visit images for our particular query with our particular constraints, and we're going to order them just by time. And we're only going to get one image since this is just a demo. So now that shows you, this might look familiar from the slides. this tells you how you can access these images. You know, it tells you the instrument, what detector, the visit number, the band. But we really only need to have a subset of those parameters that are stored in the data ID. So we can just here we defined the data ID to be just like that reference, but just the data ID. And now, finally, we can actually grab the image, which you do by doing butler.get. And since we're going to be doing source detection, we want to remove the masks that has the detected sources already. So you can do that by remove and clear mask plane. And then since we are going to be doing source detection, we want those measurements to go this is a pretty specific question, but visit images are not aligned north up. We need to align all visit images. Yes, there are instructions on how to do that. Uh, I don't remember which tutorial specifically covers that, but we do have you can do that.
Yeah,
Um,
I'll find which one and post the link in here.
yeah. Thank you for your question. But since we're gonna be doing source detection, we want those measurements to go somewhere. So we need to set up a schema for our table, right? So you can start with some minimal schema. And it does require these particular the coordinate errors, which are not included in the minimal schema, so you can just add those fields to the schema. And then you also need somewhere to go for the metadata to go. So you're just setting that up as well. Okay, so now we've found an image. We've made some basic schema for the detections to go into. Next, we need to configure the different tasks. So one reason why you might want to do your own source detection is maybe you want to only to sort of like lower the threshold for the standard deviation. So you might want to detect things at 4 sigma level, not at a 5 sigma level. So this is the part where you do that. So you start your configuration and you can change the threshold value here for the demo, we're going to use 4, and you're saying that you want to use the standard deviation. Now you need to set up the blender. For this, you don't need the to do any configurations, but you do need to give it the schema. And then lastly, the single frame measurement task where you set up the configuration, you pass it the schema configuration and the where you're going to put your metadata. And then you make a table. We're going to skip this, but you can also, this shows you how to set it up with other thresholds. Okay. Now you can actually run the source detection, and we're going to save them in these results. We'll give it the table and the actual image that we're using. Okay, and this gives you some information already about like what it detected. It detected 43,000 positive peaks and 125 negative peaks. But you can also just directly access that number. And you can grab the number of sources um, that you created. Yes. So if you use a threshold of 4 sigma, you get 3,200 sources. But if you increase that threshold, you will get a lot less sources. And warning that at this step of the process, you will get a lot of nans. So do keep going. But okay, so now we have which one was this? We ran the source detection task. Next, we need to do deep blending. So we pass it the visit image and all the sources that were detected. Now it's deblending. Okay, so for this, 391 sources were deblended and it created 1,000 children. So for a total of 4,300 sources. And then now that it has been deblended, you can do your source measurements. And the measurement catalog is the source, and you're using the visit image as your exposure. Not, they weren't just making a little copy. And then, so I think the actual detection and measurement is done, and then we want to visualize that. So we're gonna first create a little cutout of the image. So there are also some more in-depth tutorials on how to make cutouts, but for this, we're just making a little box. And then two, I don't know what's going on. Losing my voice. But we can generate a cutout here with visit image.factory. We give it the little box that we made. And then we want to display that little cutout that we made. It should show up to the right. And then the last thing we want to do is actually plot all the different sources that we detected. So yeah, that shows you, so maybe some of these would not have appeared if we had not changed that threshold. So maybe you can play around with that. Yeah, that's all I had for the tutorials. I'll pause for, I'll take the time for questions for any of the tutorials if you have any.